Alright, this is chapter 5 and we're talking about trusses. A truss is just a framework of members that are used for support. And here are some pictures of some common trusses. If you've ever seen pre-built trusses for homes, for roofs, this is exactly the kind of thing we're talking about. They're also used for bridges, for supports in the top ceilings in buildings. So you can see they have a lot of applications. In a lot of places, bridges are built from trusses. However, in South Carolina, we tend to build concrete bridges. So you don't see a lot of these unless you're looking at a railroad trestle. Right? All the members are in one plane. We're only dealing with X and Y, and they're connected to make a triangle or a series of triangles because that's a much more stable shape. Here you can see a truss that is a triangle, and when a load is applied at the top, it's rigid and stable. If you use a rectangular shape, when you apply that same load here, you're going to get a deformation. It's not rigid and it's unstable. Okay, so the shape is going to deform. Triangle is the second most stable shape. The most stable shape would be a circle. However, it's kind of hard to build that in. Alright, so these are different terms that apply to trusses, but the words we're most concerned with are the pin support and the roller support. You already know that. All the individual pieces are called members, whether they're horizontal, vertical, or diagonal. Okay? Everywhere members meet, okay, no matter how many members it is, would be called a joint. And these P's would be what we call applied loads. Okay? Whenever you have an applied load on a truss, it's going to induce a force in every member of the truss. Well, it'll induce force in most members of the truss. Occasionally you do find that some members add rigidity but actually don't hold any force. Alright, so here's what we assume on trusses. All the members lie in the same plane. The loads and reactions are applied only at the joints. We're still negating friction, and all the members are straight. There's not going to be any elongation or compression of the members, and the weight of the members is going to be very small compared to the applied load. Okay, so we're going to start with this example, and we just start off exactly like we did in chapter 4. We take the entire truss of the system and we want to find the reactions at the pins.